Hello. This video we're going to record the first part of our walkthrough for Lab 6, which is on normal distributions. So after you've downloaded this file and put it in a safe place where you know you can access it later, then we can start in the lab. So in this lab, we will be plotting the normal probability distribution function. We're going to study the properties of what this function looks like. And we're going to use it to calculate probabilities of random variables that are normally distributed. Talk about what that means, and we'll talk about what quantiles are in this context. So what is the normal distribution? It is one of the most popular distribution functions, and it has two parameters that define it, the mean and the standard deviation. So here we're going to plot one with mean 0 and standard deviation 1, and we're going to see what that function looks like. So here's the code. It's ready to go. Just run it, and we have this function. We can note the properties of it. It's symmetric. It's got the same on either side of this peak. Notice the mean is at 0. It's also got this nice bell shape. And yeah, so your first task is describe some of these properties. And then after that, we can plot many different distribution functions that correspond to different parameters. So the mean 0 standard deviation 1 graph we could modify by copy pasting this, and let's put it here. So if we want to find the mean 5 and standard deviation 1, we can plot that and see what happens. Notice the peak moved from 0 to 5, and we can do the same thing for -5 here. See what happens. Oh, yep, the mean goes to -5. And if we want to change, I'm going fast, you can definitely pause this. If you want to change the standard deviation 2, let's see what that does to our overall graph. So it makes it fatter. Ooh, the standard deviation corresponds to the spread of the data, so it spreads the data apart more. So you can finish the rest of these and then describe the patterns you're noticing. See what happens when we change these parameters. So these parameters, this bell curve, this normal distribution, is very, very commonly used to describe test scores, among other things. So if we want to compare two scores for which they're coming from different pools, there's the SAT, which is a different test than the ACT, and the scoring system is totally different. So how do we compare these scores against each other? One way to do that is use the mean of each score as well as the spread. How spread apart the data is also says something about how we can compare data. So we can do this by standardizing the scores. And essentially, this is making each distribution comparable by having the same mean and the same standard deviation. So here's how we're going to do this. First, we need to know what the mean score is for the SAT and the standard deviation. We got these two parameters. We also need to know the mean and the standard deviation for the ACT, and we're going to do something called the z-score. The z-score is going to take, here's my math equation, you don't need to mess with it, but it says, hey, the z-score, this is our standardized score that we can compare any two values with. If we take the score itself, that's x, minus this mean, and then divided by the standard deviation, we have a comparison that we can make between the two scores. So essentially, this is making each of these samples from each score a standard distribution with mean 0, because if you take a score minus the mean of that will be 0. And if you divide by the standard deviation, that will make the standard deviation always 1. Some cool algebraic properties that come when we use this formula to standardize a score. So let's find the z-scores for each of these people. Let's see how this works. So Anne, she took the SAT and she scored 300. So the x value is going to be 300. And the mean of the SAT is 1100. And we're going to divide by the standard deviation, which is 200. So that's her standardized z-score. Wait, I think I got something wrong. 1300 is her score. There we go. So she got a standard score of 1, which means she did better. Actually, this means she did 1 standard deviation better than the average person, whatever that means. We'll look at that more in context later. So let's look at Tom's score now. Tom did score of 24 on the ACT. Okay, that's his X value here. We put 24 in. And we minus the mean of the ACT. So the mean is 21. Put that in there. And what is his standard deviation? 6. So if we divide by 6, this says Tom scored a half a standard deviation better than the mean. So if Anne scored 1 whole standard deviation better than the mean and Tom scored only 1 half of a standard deviation, we can deduce from this that Anne, comparative to her peers, did better. So the question is, who scored better? Well, Anne has a higher z-score. Z-score. So we can presume she scored better. Better. So relative to like her peer group, the other people that took those exams, which for big sample size like standardized scores is a pretty good comparison. Very good. So that's something that colleges look at. How does your score compare to the mean, respective to how spread apart the data is? So your next problem is to practice another one comparing Betty and Christopher. See if you can find an accurate comparison of their z-scores. And I'll stop with this video and we'll continue with the next for calculating probabilities using these distributions. So see you there.